Hey everyone, in this video we're going to be exploring the structure of decimal numbers and several different models that you can use to represent decimals. So in essence, decimals are an extension of our base 10 numbering system. And by the time that decimals are introduced, students usually have a pretty solid understanding of the whole number place value system, where 10 ones makes a 10, 10 tens makes 100, 10 hundreds makes 1,000, and so on. And notice that each place value is 10 times bigger than the place value on its right. And because multiplication and division are inverses, this pattern also means that each place value is 10 times smaller, or 1/10 of the place value on its left. And this pattern is how we can extend the whole number system to the decimal number system. Because if you take one unit and you divide it into 10 pieces, you get a tenth. And if you divide a tenth into 10 pieces, you get 100. And so the decimal place values are just special fractions that have denominators of 10, 100, 1,000, and so on. And the decimal point separates the whole number place values from the fractional place values. So all of the whole number place values are on the left side of the decimal point, and those place values get bigger and bigger as you go farther to the left. And all of the fractional place values are on the right side of the decimal point, and the fractions get smaller and smaller as you go farther to the right. And one way that you can model this is with base 10 blocks. So to do this, you would need at least two sets of base 10 blocks that are two different solid colors. So in this case, I'm going to use the blue blocks to represent whole numbers. So if I have 10 of my blue unit blocks, that makes a 10 block. 10 of those makes a hundreds block. 10 of those makes a thousands block. And then I can use the yellow blocks to represent the decimals. So to do this, I'm going to say that this big yellow block represents or is equivalent to one of these little blue blocks. And when you're teaching this to your students, you can explain this as zooming in to look at the blue block more closely. And the yellow color, or whatever color you choose, just tells us that we're looking at a zoomed in block instead of a normal sized block. And most of your students will have enough experience with zooming in and out on technology, so this concept should make sense to them. So if we have a single blue block that looks like the large yellow block when we zoom in on it, and we divide it into 10 pieces to make a tenth, then one of those pieces will look like these yellow plates. And so these yellow plates can represent the 1/10 place value. And then if we cut that into 10 pieces, that makes one of these yellow rods, which would represent the 100th place value. And you can explain this to students that we call it 100th because it takes 100 of those rods to make one unit, which we're representing with this big yellow block. And then if we cut the 100th into 10 pieces, we get these small yellow cubes. And those are the thousandths place value because there's 1,000 of them in the large yellow block that is representing a whole. And you can extend this concept to even more place values by zooming in on one of the small yellow blocks and equating a doubly zoomed in block to be a large red block or some other color. But usually the first three place values will be enough for your students to understand the concept of decimals and dividing each place value into 10 pieces to get the next place value on the right. And one perk of the block model is that the three-dimensionality of the blocks makes it so there's a consistent pattern in the names of the place values. So the tenths and the 10,000ths will both be represented by plates. One is just zoomed in once, while the other is zoomed in twice. And similarly, the hundredths and the 100,000ths would both be rods, the thousandths and the millionths would both be small cubes. And this pattern continues for all of the decimal place values. The block model is also really awesome because it makes it really easy to see why a decimal like 0.123 is read as 123 thousandths. Because if you have one plate block and two rod blocks and three of these small cubes, then you can say that that's the same thing as having 123 of the small cubes, which are the thousands. So three-dimensional blocks are probably my favorite way to represent decimals. But that being said, it's also important to give your students other models of decimals because it will help them develop several different ways of seeing decimals. And also, other models like two-dimensional and one-dimensional models will be easier to draw on paper. So, a common two-dimensional model is the 100 grid model. And in the 100 grid model, a whole unit is represented by a two-dimensional square. So, we have this two-dimensional square, and the tenths are represented by long, skinny rectangles that you get when you split this square up into 10 pieces. So, each one of these long, skinny rectangles represents a tenth. And then if we cut those into 10 pieces with these horizontal lines, those are going to represent hundredths. And you can see that there would be 100 of these little squares inside of this big square. And you can even continue this pattern by cutting up one of these little squares into 10 pieces or cutting those into 10 pieces and so on. So if we wanted to model a decimal like 0.582, we could say, okay, well, I have 5 tenths. So I'll shade that in red to coordinate with my place value. So I'd have 5 tenths like this. And then I would have 800. So 1, 2, 3, 4, 5, 6, 7, 8. And then I would have two of these little pieces right here, which would be thousands. And that's how you could use a 100 grid model to represent this decimal. And obviously, this model usually works best for decimal numbers that don't have very many decimal places, because once you get to the 10,000th decimal place, it's really hard to split the teeny tiny squares into 10 pieces. You can also use a number line as a one-dimensional model for decimals. So if we take the distance between 0 and 1 and split it up into 10 equal-sized pieces, each one of those spaces between these marks will be 1/10 of a unit. And then if you split the space between those marks into 10 more pieces, those would be hundredths. And if you wanted to, you could even split up the space in between those into 10 pieces to get the thousandths place value. And so to model this decimal 0.582, I would go 1, 2, 3, 4, 5 tenths, then 1, 2, 3, 4, 5, 6, 7, 8 hundredths, and then 2 thousands, which you can't really see it very well because they're really tiny, but you'd get a point about right here. And that would represent the decimal 0.582, which we read as 582 thousandths. And this number line model for decimals is very relevant to the metric system of measurement because the metric system for measuring one dimensional length is based on the unit of a meter. And if you stick 10 meters together, you get a decameter. 10 of those put together makes a hectometer, and 10 of those makes a kilometer. And this is just like our whole number system. But if you take a meter and cut it up into 10 pieces, you get a decimeter, which is about the length of an adult finger. And if you split that into 10 pieces, you get a centimeter, and a tenth of a centimeter makes a millimeter. So, when you're teaching decimals to your students, it can be really helpful to link the idea of decimals to the metric system because the metric system is based on the decimal number system. Our textbook also suggests using equal sharing problems as a way to introduce decimals. For example, the structure of the base 10 numbering system naturally comes out through a problem like this one. Because if you have 246 cupcakes and you want to divide them equally among 10 bakeries, then you could model the cupcakes with base 10 blocks. And probably I would actually use base 10 blocks that are all the same color so that you can stay consistent with the color coding for whole numbers and decimals. But the applet I was using to show these graphics didn't allow me to change the colors. So we'll just go with it as it is. So if we wanted to take these 246 cupcakes and split them up into 10 equal sized groups, then you could do it place value by place value. So each of the 200 blocks can be cut up into 10 rods each. And each bakery would end up getting two of the rods because they would get one rod from this 100 and 1 rod from this one. And then if you take the 4 rods and cut those up into 10 equal sized pieces, which are representing cupcakes, each bakery will get 4 cupcakes. And then if you take the single cupcakes and cut those up into 10 pieces, each bakery will get a tenth from each of these little blocks. So you would, show that you're cutting them up into 10 pieces, and each bakery would get 1/10 from each of those single cupcakes. And so the number of cupcakes that each bakery would get would be 24.6 cupcakes, because the point 0.6 is the 6/10 that we got from each of the unit blocks being cut up into 10 pieces. And notice that each of the digits shifted by 1 place value to the right. So when we did 246 divided by 10, the 200s became 20, or divided up to get 20, and the 4 10s divided to 4 1s, and the 6 wholes divided to 6 tenths. And something similar would happen in a problem like this one, except that in this case, each place value would shift 2 places to the right, because if you divide by 100, that's the same thing as dividing by 10 twice. And when you're teaching decimal notation, it can be helpful to ask students to write a decimal number in expanded form and vice versa. So to write the expanded form of a decimal number, you just multiply each digit by its place value. So to write the decimal 25.489 in expanded form, you would do 2 times 10, because the 2 is in the tens place, plus 5 times 1, plus 4 times a tenth, plus 8 times 100th, plus 9 times 1,000. So this is one way to write expanded form. You can also simplify the multiplication and write this as 20 plus 5 plus 4 tenths plus 8 hundredths plus 9 thousandths. That's also considered expanded form. And writing decimals in expanded form can help your students solidify their understanding of the decimal place values as just being special fractions with denominators that are powers of 10. And when they're first learning decimals, some students may have a hard time identifying which place values are which. And one really easy way to help them master the notation is to explain that all of the whole numbers are on the left side of the decimal point, and all of the fractional place values are on the right side of the decimal point. And the place values expand out from the decimal point. So the first whole number by the decimal point is the ones place value, and each of the following whole number place values are just 10 copies or multiples of 10 of the previous one. And then the first decimal number next to the decimal point is a tenth of a whole, and each of those following place values are just a tenth of the previous place value. And writing decimals in expanded form is also really helpful for helping students understand how to convert decimals to fraction form, which is when the decimal is written as a single fraction. So students can find the fraction form by writing the decimal in expanded form and then finding common denominators to add all of the terms together. In this case, the least common multiple of 10, 100, and 1,000 is 1,000, and so the common denominator would be 1,000. And by multiplying 8 over 100 times 10 over 10, we get 80 over 1,000. And when we do 4 tenths times 100 over 100, that gives us 400 thousandths. When we multiply 5 times 1,000 over 1,000 to give us the common denominator of 1,000, you get 5,000 over 1,000. And same thing with the 20, you'd multiply by 1,000 over 1,000 to get that common denominator of 1,000, which gives you all of these decimals that have the same denominator. And then you can add them all together, which gives you this single fraction, which is the fraction form of this decimal. And if you do several examples with numbers that have a variety of decimal place values, it probably won't take your students very long to realize that you just need to look at the last place value to find the common denominator, which would be the denominator of the fraction you end up with. And then the numerator has the same digits as the original decimal. You just don't have the decimal point. But it's important to let your students discover this relationship for themselves so that they understand why the fractional form of a decimal works the way that it does. And this is also very helpful for helping students understand why we read the decimals the way that we do. Because if you were to take this decimal and write it out in words, the way you would write it is you would say that it's 25, which is the whole number part of the decimal. And then you would use the word and to denote the decimal point. And then you would write it as 489,000. And basically, the only difference between this format versus fractional form is in fractional form, it's written as a single fraction. And in word form, you just have the whole numbers separate. And then you have the fractional part of the number written as a fraction. So it's kind of like this is like the improper fraction. And then the word form would be like a mixed number, kind of an idea. So, to summarize, decimals are an extension of our base 10 number system, and you can use three-dimensional models or two-dimensional models or one-dimensional models to visualize decimals. And the process of writing decimals in expanded form and fraction form and word form can help your students deepen their understanding of the relationships between the place values. So, if you have any questions, let me know, and I hope that you have a great day.